box of supplies. And then I'm going to show you how to just prepare the electrodes for the electrolysis of water. And fold them. Each one separately, yeah. And fold them. You're just going to fold them over again and again and again. Lengthwise, yeah, the longest way, and then doesn't matter until you get 2 of these. Then in a cup of water, you're going to get a cup of water. You're going to need a couple of cups. And because you'll probably need one just for some extra water. I'm going to put some water in here. Fill this up. Put the electrode in. Okay. And then your finger. Tap this. Turn it upside down. Put your finger in the water, release it. Okay, so here's what I want you to do. I've got this water. I also have some salt over here. I have in your box a scale. Here's a scale. And I want everybody to do a different experiment, and everybody decide on whether you're going to do no salt, a little salt, a lot of salt, and you're going to find out how long it takes to collect a test tube of either oxygen or hydrogen, whichever gets there first. Okay? Of course, we've got the first thing of trying to determine which test tube will have the oxygen and which test tube will have the hydrogen. We're gonna do electrolysis of water, and we're gonna see who can most efficiently get the products of electrolysis of water. And I've got all the supplies here. Okay, does anybody know what electrolysis of water is? Yes.
It's the movement of electrons from one place to another.
Okay, and what's the result of this?
Separate the hydrogen and oxygen.
Okay, so the one thing is we're going to separate hydrogen and oxygen from water. Now, I want to know, that's okay. We're going to separate, oh, you're probably like, I think it's like where you do these. Matches? Okay. Right. Oh yeah, well we're going to do something.
Yeah.
Okay. We're going to blow something up. So the thing is, we want to separate oxygen and hydrogen. You're going to have to figure out in the test tubes which tube is hydrogen and which tube is oxygen, and why it is the case. I've got, all right? And then the second part of this is determining how much or no salt you're going to put into your mixture. Okay? Now, first of all, tell me what you did. What happened? Sort of give me your observations. Now, here's the question that I have. We're going to do electrolysis of water. Now, I want to know, you've got water and some other stuff over here. Does pure water conduct electricity? Why? Okay, so are there two ways that we can determine what's in the tube? So the one way is that we can look at the terminal. If it's positive, it's collecting the oxygen. If it's negative, it's collecting the hydrogen. Or we can visually inspect the tube, and whichever tube is filled first, essentially, in other words, it'll be almost all the way filled with one gas. The other tube will be about halfway filled. So that means the hydrogen is the full tube, and the half full one is the oxygen. Okay? And something to ignite it, spark, heat source, and then what else?
Oxygen. And then it's something to burn.
And then
fuel source. And then a medium? No. Yeah, you can't have it in a vacuum. I guess that would be the source also.
So what do you need?
I know it's a fire starter. Air? No. Oxygen? No. You don't always need oxygen. You need air?
Okay, so I don't know.
Okay.
So you need three things essentially for combustion to take place.
You do need oxygen.
So you need hydrogen.
You need something to burn, you need heat source, and you
And you
need
oxygen.
need oxygen. Okay, so let me ask you, I have a question. I'm going to be an astronaut. I'm going to go to Jupiter. Because Jupiter is mostly hydrogen and helium.
Yes, it is.
Okay? So I'm going to go there. I'm going to go into the atmosphere. I'm going to take a match.
No.
Will it explode?
No.
Why? Here's the deal. The space shuttle, the space station, they need to have oxygen in space. So the question is, well, first of all, how do we get this pure oxygen? And then also, the oxygen used for for powering things on board the space station that we'll talk about in a second. So I've got about how much breathing air do we have in here?
Not much.
About a second, maybe not even that. All right, so if we try to take this to the space station, this would be difficult. What's the other
They
problem?
might not let you on.
No, I would definitely get stopped at TSA.